Number 19. If f is continuous on this closed interval from 2 to 5 and differentiable on this open interval from 2 to 5 with these points, so that's 2, -4, and the other point is 5, 14. Which of the following statements must be true? And that's important. Must be true. Not can be true, must be true. All right, just a quick scan. It looks like we're given information about f, f prime, and f double prime. Let's read the first one. It says f of x equals 6 has a solution between this interval. Now keep in mind that these numbers, and these numbers are all x values. So we know that on our graph at 2, we're going up or down to -4. So we have a point right there. We also know at 5, we're going up to 14. So since we know that we're continuous and differentiable, these 2 points are going to be connected in some way. We don't know exactly how, but we do know that they are connected. So this question, or this statement, says that there exists a solution for y equals 6. And that is true. If this line that is connecting these 2 dots is continuous, then that means for my line that I drew right here, this x value would be the solution. So we would say yes for that one. All right, you can circle it or put a check mark next to it. Next, for the f prime, it says f prime equals 6. That has a solution for between this interval. Now this means that there's a slope that equals 6 between 2 and 5. Not at 2 and 5, but between 2 and 5. And so for that, we got to think about the mean value theorem. And the mean value theorem says that the slope between two lines equals another slope somewhere on the curve. Now I just drew a random curve. It looks like I could draw a tangent line right there and be parallel, so that these 2 lines, this secant line and this tangent line, would have the same slope. So we need to find the slope of this secant line. We know that by going 14 minus -4, and then 5 minus 2. So I get 18 on the top, and on the bottom I get 3, which equals 6. So the slope of this guy equals 6. So because we know MVT, and MVT applies because we have a continuous and a differentiable function in a given interval, that means there does exist a c that I could plug into f prime to give me a 6, because the secant line is a slope of 6. So this one is also true. All right, now let's go down to number 3. It says f double prime of x equals 6 has a solution in this interval. Okay, well, this is kind of weird because we don't have like an MVT for f double prime. But we could treat f double prime like f prime, but we have no information about what f prime of 2 is and what f prime of 5 is, and then being able to apply the mean value theorem. So while this can be true, that is not a must be true. So I'm going to put an X on that guy, and we're going to circle C for our answer. All right, the particle is moving on an x-axis with position given by this cute little formula. T is time, and we're in this interval. We're from 0 to 2 pi seconds, or whatever the t is. It doesn't look like it tells us. Then the particle is only at rest when, and I will quickly say, when the speed is 0, or the velocity is 0. If we're given a position function, we got to take the derivative and we would get the velocity. If we took the derivative again, we would get acceleration. But it looks like we only need the velocity function or formula right here. So let's go ahead and find v. And in order to find v, we have to take the derivative of the position function. So we would get 1 plus, and then the derivative of sine is cosine 2t, and then I have to multiply this by the derivative of 2t, which is 2, so I'm going to put 2 right there. So there's my velocity. Let's set this equal to 0 to find out where our velocity, our speed, is 0. Let's see, if I move 1 over, I get negative 1, and then I'll divide by 2, so now I have cosine of 2t equals negative 1/2. So we're thinking about my unit circle, and because we're dealing with cosine, I'm trying to figure out, or remember, what values give me a negative 1/2. So if I'm thinking about my unit circle, I remember that this one right here gives me a rad 3, I'm sorry, not rad 3, 1/2 rad 3 over 2. This one over here gives me a negative 1/2 rad 3 over 2. And this one right here gives me a negative 1/2 negative rad 3 over 2. And this one right here gives me a positive 1/2 rad 3 over 2. So those are all the points that give me 1/2 for the x. I don't care about this or this because it looks like we need a negative 1/2. What I do need to know is what is this angle and then what is this angle. And since this is pi over 3, this right here must be 2 pi over 3. So we have 2 pi over 3 equals 2t. So the angle has to equal 2 pi over 3. And then if I go right here, that would be 3 pi over 3. This would be 4 pi over 3. 2t should also equal 4 pi over 3. All right, so let's solve it. I multiply both sides by 1/2 over here to get 2 pi over 6, which simplifies to pi over 3. So there's 1t. And on the other side, we get t equals 4 pi over 6, which simplifies to 2 pi over 3. It looks like those are my two answers, but I need to confirm that we're inside our interval that was given to us earlier. It looks like we are. Pi over 3 and 2 pi over 3 are between 0 and 2 pi. Now I can see that D has our two solutions. But E also has the two solutions, and we have 4 pi over 3 and 5 pi over 3 right there. Now that kind of concerns me. Like, how can those also be answers? And so, yeah, let's think about cosine for a second. Cosine goes like this, and it stops usually at 2 pi. But because we have a 2 right here, that changes our period. And so the period, instead of it being 2 pi, is just pi. And remember, we go from 0 to 2 pi. So if I go all the way to 2 pi, then we're going to do the same thing right here. We're going to repeat it. So that means we would have 4 answers. Because if I'm thinking about negative 1/2, which would be right about there, because this would be 1, or negative 1, we get an answer there, an answer there, an answer there, and an answer there. So we actually do have 4 solutions. So this would be pi over 3. This would be 2 pi over 3. Now, how do we figure out these ones? I want to confirm that these are the other 2 answers. And the answer to that question is you add the period. So since the period is pi, I just got to take pi over 3, add pi to it to see if I get that number right there. So if I have pi over 3, and I add pi to that, that would be the same as going 3 pi over 3 added to pi over 3. That would be 1 plus 3, which is 4 pi over 3, which does check out right here. Hey, check that out. And I bet if we add pi to the 2 pi over 3, we would get our other one. It's kind of tricky because this is a periodic function or reciprocal function. I guess that's the wrong word, reciprocal. But it repeats itself, the function does. And so we got to be careful with these ones and make sure that we get all the answers when we're doing that. So the period helped us out at the end. I hope that helped.